Alright, we're going to talk about partial fraction decomposition. But before we do that, we're going to review a few things and talk about some vocabulary. Alright, before we can talk about something called decomposition, which is the opposite of composition, let's talk about what we mean by composition. Okay, so basically that's the idea of adding and subtracting what we call fractions or rational expressions. In order to add or subtract fractions, which is the idea again of composition, you have to have a common denominator. So one of these denominators is x plus 1, the other one is x minus 3, and those are definitely not the same. In order to make them look the same, we will multiply those denominators by each other. Okay, we would call this the LCD, or the lowest common denominator. Now, when we multiply the bottom of a fraction by something that wasn't there before, we also have to do the same thing to the top. So I'm going to multiply top and the bottom of the right fraction by x plus 1, and the top and the bottom of the left fraction by x minus 3. Now let's rewrite what we have at the top. I would have to distribute the 3, so that's 3x minus 9. And at the top I would distribute the 1. Well, that just gives me x plus 1. The denominator is exactly the same as it was for both of those fractions. Alright, so now that we have that common denominator, now we can actually combine the numerators together. So we keep the same denominator, and we add the like terms on top. So that's 3x plus x, that's 4x, and then negative 9 plus 1, that's a negative 8. Now if you wanted to, you could multiply out or FOIL the denominator. Let's go ahead and just do that, see what it looks like. First times the first would give me x squared. Outer times the outer would give me, was that x? Inner times the inner gives me negative 3x, and then last times the last gives us a negative 3. When I combine the like terms, we get negative 2x for that middle term. So this is what we would call composition. So what is decomposition? The purpose of this video is to talk about decomposition. Decomposition means I want to reverse this process. So I want to go from here to here to here to here. My final answer is actually going to be what we call the partial fractions. What were the original two fractions that we added together so that we achieved this one fraction in the end? So what we're going to start with decomposition is we're going to start with this more complicated looking fraction, and then we're going to go back to the two simpler fractions that we actually would have added together to obtain this more complicated fraction in the end. So our final answer will be these, what we call these partial fractions, these simpler fractions that we started with at the beginning. Alright, before we actually get started into some examples of decomposition, we're going to look at some vocabulary. We're going to be looking at 4 different types of decomposition, and the type is based upon the result of factoring the denominator. Okay, so one of the things that you'll have to remember how to do is how to factor. Okay, quadratic formula doesn't actually work here, so make sure that you know how to factor before we go into these. Alright, type 1. Type 1 is what we would call a non-repeated linear factor. So when I factor my denominator, let's say that I end up with something that looks like this. Okay? Don't really care about what's happening at the top. Just focus on what happens when we factor to the denominator. And let's say we factor it completely and this is what we get. This is what we would call non-repeated linear factors. So non-repeated means that each of those factors that's multiplied together only appears one time. So it doesn't appear more than once. What do we mean by linear factors? Okay, linear factors means that when I look at all of these variables that appear in those factors, that all of those variables are only raised to the power of 1. Alright, so when we say linear, we're looking for something maybe like x to the power of 1, very specific to having an exponent of 1. Alright, so what do we mean when we say repeated linear factors? So repeated means that we have a factor there more than once. So it's used more than once, it's repeated. Okay, so for an example of that type of denominator, maybe I have something like x squared, x minus 2 cubed. So we notice that we have that x there twice. We have x minus 2 there 3 times. So the exponent actually changes how many times that linear factor appears. Let's say I have x plus 3, which is a linear factor, but maybe I have it there 5 times. So these would all be called repeated linear factors. One thing that we have to actually be careful about is the idea of x squared. X squared sometimes trips us up because you would say, well, hey, that variable x doesn't have an exponent of 1, it has an exponent of 2. Doesn't that make it quadratic? So here's where we have to be careful. Why is this considered to be a repeated linear factor? Well, a repeated linear factor means that it cannot Well, a repeated linear factor means that you are able to take this factor and break it down into 2 linear factors multiplied together. So if I can take x squared and break that down into 2 linear factors multiplied together, then we would call that a repeated linear factor. So the idea here is that x itself, x minus 2, and x plus 3, all of these are linear factors. The fact that they're there more than once, so twice, 3 times, and 5 times, it's what makes them repeated. Okay, so we're going to be careful. X squared can be broken down into linear factors. If it can be broken down into linear factors, we do not consider that to be quadratic. We consider that to be repeated linear. Okay. So we got to be careful there. Don't really care what happens at the top again. We're just focused on what happens when we factor our denominator as much as possible. Okay, type 3, non-repeated, irreducible quadratic factors. Okay, so this time we're talking about non-repeated. All right, what do we mean by irreducible quadratic factors? Okay, irreducible means can't be factored, which means you can't be broken down. Into linear factors. Okay, so the word there means it cannot be factored or broken down into linear factors. Can't be. All right, so what are some examples of that? All right, x squared plus 4. If that's a denominator, that's part of that denominator, that's actually an irreducible quadratic factor. Now quadratic, typically we associate quadratic with the idea of an exponent of 2. Okay, so what we're looking at basically is irreducible quadratic factors means that I see an exponent of 2 on that variable, but this cannot be broken down into linear factors. This right here does not factor or break down. Okay, if you remember from algebra, that's actually what we call a sum of squares. And a sum of squares does not factor down into linear factors. You will see sum of squares pop up a lot in this section. And you want to be aware that when you see a square plus a square, you might be tempted to try to factor that, but it does not factor. Okay, another example that would be something like x squared plus 1. Even x squared plus 2. Alright, even though 2 is not what we call a perfect square, this is also something that cannot be factored down into linear factors. Now you might try. So you might say, well, I can do it. X plus 1 times x plus 2, isn't that how that factors? Well, before you decide that you're factored it correctly, wouldn't you have to multiply it out to check it? Let's check that. X squared, is that 2x plus x plus 2? So yeah, we got the x squared and we got the plus 2, but didn't you get something else in the middle? You got 3x. That is not the same as that. Okay, so all of these things that I've listed are things that have x squared in them, and they cannot be broken down into linear factors. Okay, they do not factor. Another example would be if you had denominator or something that looks like this. Okay, that is actually also an irreducible quadratic factor. That has an x squared in it, okay, and it does not factor down into linear factors. So you can try that and see. Okay. Now let's talk about something that does not fit into this category. X squared minus 4. What category does x squared minus 4 fit into? This is actually what we would call, from algebra, a difference of squares. Not a sum of squares, but a difference of squares. Now, difference of squares, I can actually factor that as x plus 2 and x minus 2. Now, both of those are linear factors. Right? So, since x squared minus 4 can be broken down into linear factors, they're not the same, so they're not repeated. But since it can be broken down into linear factors, this is actually not an irreducible quadratic factor, because I could reduce it into linear factors. This would actually fit into the category up here of non-repeated linear factors. Okay. Alright, so if you have something that has an x squared in it and you cannot factor that down, you cannot break it down, then it's an irreducible quadratic factor. If you can take that x squared and break it down, then it actually fits into another category that represents linear factors. What's a repeated irreducible quadratic factor? Okay, so let's talk about that. Repeated means it's there more than once. Irreducible quadratic factors means you cannot break it down. So that would mean take the irreducible quadratics that we have above and then put parentheses around them and then put them there more than once. So x squared plus 4 we said is an irreducible quadratic, and it is there more than once, so it's there twice. So it's a repeated irreducible quadratic. All right. X squared plus x plus 1. Let's say it's there 4 times. All right, so x squared plus x plus 1, that is an irreducible quadratic. Does not factor down. But in this section, we have it there more than once. So it's actually in that denominator 4 times. All right, so a repeated irreducible quadratic factor means I have an irreducible quadratic factor that is there more than one time.